This is lesson 2 for the total surface area and volume unit of work. And this will be looking at the total surface area of prisms and cylinders. The learning goal for this one is to look into what total surface area actually is and how the formulas on 2D area shapes can apply to 3D shapes in regards to the total surface area. And the success criteria for this one is to be able to solve problems involving the surface area and volume of right angle prisms, and to also be able to solve problems involving surface area and volume for a range of prisms such as cylinders and composite solids. I've taken 2 examples straight from the textbook that looks into different approaches for how to tackle a question where you're looking for the total surface area. Now, before we get into that, we want to know what total surface area actually entails and what it actually is. And it says it within the name, total surface area. So if we break this down, the area is just how many squares can fit within a 2D shape. And total surface just means that if we were to look at a 3D solid, there's a total surface, or in other words, there's an outside that belongs to that shape. So we've got a top, bottom, side, front, and back. And all we're doing is just finding out the area of the exposed sides of a 3D prism or shape, and then getting the areas of all of them, and then adding that up to get its total surface area. Remember, surface just means the outside of something. And all you need to know, the prior knowledge for this was just in the previous exercise, is just trying to get the formulas for all the areas that you need. Rectangle, triangle, parallelograms, rhombus, circles, that's pretty much it. Squares, obviously, which you can use a rectangle formula as well. So how do we tackle this? How do we tackle these 2 questions? So let's have a look at this. This is saying that we need to find the total surface area of this rectangular prism and cylinder, and we're going to round the answer to 2 decimal places when necessary. We're going to look at this first face. So this face, let's look for the area of this first face here. And to get the area of a rectangle, it's just length times width. All this information has been provided to us. So length is 8, and the width, or in this case, the height for this one is 3 centimeters because it's also 3 here, so it must be 3 here. So to get area 1, we'll call it area 1. This is just 8 times 3, which is 24. And then we also know there are 2 lots of this 24 because we also have to do the area on the back side, which is going to be 24 as well. Let's be specific, this is 24 squared centimeters. That just means there are 24 squares that can fit onto the front face. 48 for the front and the back. Area 2, we can do the side. So this can be 5 by 3. So this is equal to 15 squared centimeters. And then area 3, which we can do the top, this can be 8 by 5. So this will be 8 by 5. So this is 40 squared centimeters. So if we want to be specific with this one, area 1 here, area 2 on the side, I'm trying to write it as flat as I can, area 3 on the top. Now, when we get this, we're just going to double these sides because we also want to compensate for the other side as well. So 24, for both sides, it's 48. For both sides for this one, it's 30. And for both sides for this one, it's 80. And then to get our total surface area, which we'll call TSA, this is just adding all of those areas up. So 80 plus 30 is 110. And 110 plus 48 is 158 squared centimeters. So that is our total surface area. Or in other words, if I were to get 1 by 1 centimeter square, and I were to paste this on this box, it will cover the whole box, and exactly 158 of these squares will cover this whole box. For question B, we're now looking into a cylinder. This one gets a little bit tricky because we need to know the area of 3 sides. We need to know the area of the two circles. Once we find one of the circles, the other circle's easier. Or easy, not easier, easy, because it's just exactly the same. But we also need to know how to find out what the area of this cylindrical cone part. And the tricky thing is, there's no such real formula to figure this out. But then technically there is, once you kind of know what this shape is as a 2D shape. So let's say if we were to get a cone of some sort, right? Don't laugh at my drawing abilities. Okay, let's just say this is a replica of the cone, and there's a radius and there's like a height of some sort. And then I decide that I'm gonna, remember this is hollow. Okay, this is hollow. So it's one of those, like a toilet roll of some sort. And then I say, okay, I'm going to cut along the edge here. Right, I'm going to use a pair of scissors. I'm going to cut. And so what will happen is once that cut is made, I'll end up having something that pretty much sort of looks like this. There's this kind of cut that has happened through the middle, and then there's this inside part here. But it's been cut out. So I've cut it, and I were to then want to roll this out as flat as I can. And so when I roll this out, what ends up happening is I end up getting a rectangle. This is a rectangle, and this rectangle, we know the formula to get the area of a rectangle. It's just length times width. And what is the length and what is the width? Well, the length, if we were to map this out to what we previously had, that length is just the height of that cone. And we know what the height of this cone is. It's given to us as 5.3. And then the width, what goes right around, well, if we were to curl this back up again to its original spot, the width is just the circumference of the circle, and we know what the circumference of a circle formula is. It's 2 pi r. And we know what pi is, 3.14. We multiply by 2. But then what's the radius? Well, the radius in this case is being given to us as 1.7 meters. So we've got all the relevant information that we need. We just have to put it into a formula in a way that makes it work. We're forcing it to fit the prior knowledge that we already know of what the area of this is and how to get the circumference of the circle. And then obviously to get the area of the two circles. So let's get area 1. Let's get area 1. When we get area 1, this will also give us the circle area as well, the back one. So area 1, to get the area of the circle, is pi r squared, which is just pi times whatever the radius is, 1.7 squared. Now, it's going to seem a bit weird what I'm going to do next, but I'm actually not going to work this out straight away. I'm just going to keep this in its most natural format. And the main reason why is just to do with accuracy. Okay, because if I work this out and then round it to 2 decimal places straight away, then multiply by 2 to get the other side, it starts losing its accuracy because I've done the rounding prior to getting the full area of what it is. So I'm just going to leave this like this, and I'm also going to include that the back circle is also area 1. So this means that whatever I get here, I also have to multiply this by 2. So it's this, whatever this area ends up being for the circle, I have to multiply it by 2. But I want to rewrite this in a different format. I want to do 2 pi times 1.7 squared. So that 2 is just jumped to the front, and we just left it as this. We'll use the calculator to work this first part out later. Now let's get area 2, which is this rectangle that flips right around. So area 2. Now, area 2 is equal to length times width, because we've determined that it's going to be a rectangle. The length is going to be whatever the height is, which is this 5.3 if we were to stand this up and look at it from top to bottom. So it's 5.3, and this is multiplied by its width, and we determine the width, which is the circumference of a circle, which is 2 pi r. So 5.3 times 2 pi, and the radius is again 1.7. So times 1.7. So I know we kind of have this messy thing that we're not working out. We're so used to putting this into our calculator and let the calculator work it out. But we're going to just hit this all in one chunk. So to get the total surface area, is this first part we found out, 2 pi times 1.7, plus this part that we found here for the rectangle, 5.3 times 2 pi, times 1.7. And I'll just put these in brackets to show you the origins of where these came from. This one from here, and this one from here. So our total surface area, in this case, this is where we can use our calculator to figure this one out. So let's put this all in the calculator. This will be 2 times, remember to get pi, shift, and this button here, times 1.7, that should be squared. So let's square this, so make sure I write squared here. And this is going to be added to 5.3 times 2 times pi times 1.7. Close that bracket. If you get an answer like this, press the SD button, and it's 74.769. So that rounds up to 74.77. 74.77 squared meters, and it's meters because the context has been given to us within meters, so we leave it as meters, and that will be the answer for that example. We're now going to look at finding the total surface area for this composite object here. Now, this one's going to get quite tricky because we've got quite a unusual shape, and we're trying to find out the areas of everything within the outside. Now this is really simple when you can get the areas of one shape, one solid and the other solid, but you've got to realize that there's this little part in here. This is a cylinder on top of a prism. This little part in here is not being shown, so we've got to compensate for this. So if the little part is not being shown here, but it's being shown on the top here, really we don't need to necessarily find the area of this, because we can just assume that it covers that section here. So all we're doing is we're just trying to find the total surface area of everything on this prism, and then just this little rectangular part here. Because if you were to see it from bird's eye view in a flat version, it's just this rectangle with a circle, but that area is still just going to be that all covered. It's going to be here and then covered on the top here. So we have to be strategic with this. Let's just work out the total surface area of everything we have on the prism, and then work out what this rectangular shape is. Remember, when you cut it and it looks like this, which ends up being a rectangle of some sort, length times width, and we'll just go from there. All right, so first one, let's get total surface area. I'm gonna be really shortcut-y, if that's a term, with this one now. Total surface area of shape 1 being just a prism. So this one is just going to be, this is 20 and 10, so it's 2 lots of 20 times 10. So this is for the front and the back, plus 2 lots of this is going to be 10 by, now we know that this is going to be 20 as well, even by the fact that this line here, anywhere we see this line anywhere within the shape, indicates that it's going to be 20. So we know this is also going to be 20 here. So this is 2 lots of 20 by 20. So we're getting the bottom and the top. And then we're just going to add 2 lots of whatever the side one is, which is I seem to have made a mistake somewhere. 20 times 10, there it is, 20 times 10, 20 times 20, and then we also have 20, what is going on? Times 10. 20 times 10. It's another lot of 20 times 10. This is why I'm getting so confused, because we've got front, we've got the back, we've got the side, which is also 20 times 10, and then we've got the top and the bottom, which is 20 times 20. The fact that these both are 20 is what confused me. Alright, so we can work this out. Apologies for that. Got there in the end. Let's just put this straight into our calculator. I'm not gonna leave it because I know there's no pi's or anything, so it's gonna just be a straightforward answer. And let's get the answer to this. Alright, once this has been put into the calculator, we get 1,600 square centimeters. It's quite a bit. It's quite a lot, but considering the sizes of these, that makes sense. Okay, so now we just need to get the total surface area of shape 2, and 2 is the cylinder, the side of the cylinder, because we're not really doing the top. We don't need the top, but we do need that 6 centimeter piece of information, because remember the cylinder is length times width, and with that length times width, the length is the height of it, which we can see as 8. So this is going to be 8 times 2 pi r, 2 times pi times the radius, and r being 6. So there's our there's our height or length, and there's our width, which is the circumference of that circle. And then when we put that into our calculator, we can actually do a little bit of tidying up. 8 times 2 times 6. This ends up being 96 times pi, because we know 8 times 2 times 6 is 96. I'm just going to leave it as 96 times pi per hour now, or 96 pi. And then on the calculator, we've got total surface area of one and the total surface area of the other one. To get the full total surface area, we're just going to get total surface area 1 and just add it to total surface area 2. Or in other words, 1,600 plus the 96 pi. And so we will put this into the calculator to 1 decimal place. .6 1901.6 square centimeters. So total surface area of composite shapes can be a bit tricky, but if you can find shortcuts like I just did, it saves you from having to try to find out what the area of these two circles will be, and then taking away one, when if you just look at it on the top view, it's just a full rectangle, which is a circle on the top. It makes no difference trying to get that full area anyways. And that's all there is to this one. So go ahead and check the log sheet to see which questions you need to do for this exercise. And until then, I'll see you in the next video. Bye bye.